Hey guys, this is Ed from Mission Ed Possible. Welcome to episode 8 of my Atari 8-bit assembly language tutorial series. So in previous videos, we've been using characters, and that's great, except that, that becomes a little unwieldy. We're going to want to be using tiles. And so today we're going to be looking at how we can modify our code to be able to use tiles instead. We also have a bug that needs to be taken care of, so we'll be taking care of that as well. So let's get into it. So on my last video, there was a couple people that had called out that I had a bug in my code. So I want to call them out first off. It's Fitty P, Brian Wild, and Taking Bites. Thanks for the call out, guys. Keeping me honest here. So the bug was actually in this clear PMG procedure. And what the deal is it has 80 here. And the problem is that I'm off by 1. When trying to clear this data out here, to clear this memory, it's starting at 80 and going down to 1 effectively as far as the clearing goes. So all we have to do to fix that is, instead of decrementing the X register after all this, we're going to decrement it first. And that's all we have to do. So what it comes in as is 80. And then before it starts using it, it goes to 7F. And then, it goes 7F. It's going to be clearing the 6200 here, 7F, and then working its way down. And then it's going to start at, 6280 and then work its way down, things like that. Starting at 80, and then once it goes down to 0, it's going to decrement it, and it's still going to work at 0. Then it's going to exit the loop. Yeah, I wanted to get that taken care of. This was one of those bugs that probably would not affect anything. However, as Brian pointed out, it's one of those problems that if you don't fix it, it could show up some weird way, and it can be a real pain to try to figure out. So I'd much rather take care of it now. Obviously, if you see anything else, if you guys see anything else wrong, definitely make a comment. I really appreciate it. I'd like to make this code the best I can. I'm always looking for constructive feedback on any of this code. And but anyway, thanks for the comments, guys. I really appreciate it. Okay, so what we're going to want to do today is convert our display map function to use tiles instead of characters. If you look down here, we have all of our left and right characters that make up a tile. So we have things like 2 and 3, which are supposed to be a wall, 2 and 3 a wall, and then we have like 4 and 5, which are floor, and then we have like 6 and 7, which are a door, and stuff like that. So what we're going to want to do is we're going to want to convert that into a single number for each one of these. So it's going to be a tile. So if you look at 0 and 1 will equate to 0. 2 and 3 would go to 1. 4 and 5 would go to 2, etc., etc. And the way it works out is that in order to calculate that, we're going to just multiply by 2 for the left-hand side character, and then add 1 to do our right-hand side character. And so it's going to make our map a lot cleaner, and it's going to make it a lot easier when we're dealing with our map generation stuff. So let's update the map to use the new format. So what we're going to do is we're going to use 1s, as I said, for the walls. And let's just go ahead and copy and paste these because I'm lazy. And so we have 20 characters across. This is going to be our top wall. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 18, 19, 20. Okay, perfect. Just wanted to double check. And so we're going to want this for the top and the bottom. And what I'm going to do here is I want to recreate our scene. But to do that, I'm going to actually create a big room to start. So let me go ahead and do this. And then we'll fill in the empty spaces, rather the center, with the floor tile. So I'm going to go ahead and put a bunch of these in there. And we have, it's 12 rows high. So we're going to want to have 10 rows of this and 2 rows of the walls up and down. Okay. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. So we need one more. So let's go ahead and paste that there. So already you can see that this is much, much cleaner. So we need to put in our walls here so that it looks similar to the previous one. So I believe we have like this, and then for the walls, and then to look at what we need for the door, it's 6 and 7. So divided by 2 is going to be 3 and 4. So well, we don't need to worry about the 4. We just put a 3 there. And then our door, or not our door, and our downstairs is going to be 10 and 11. So we just need to divide it by 2. So that's a 5. So we're going to put a 5 right there. Okay. So this is the equivalent to this, but using tiles. Okay. So I'm going to go ahead and comment these out. That's not what I wanted. Boom. Okay. Now, what we need to do is we need to update our display map function to use to do the calculation for us. And we're going to do this a little differently. We're going to end up using a macro for this. And so I'm going to call it blit row. And I'm going to be passing in our map location as well as our screen location. Okay. So we're going to pass in map and screen. This works kind of like a function, but it's really, really simple. So what we're going to do here is we're going to be using both the X and the Y registers for iteration. So we're going to use X to iterate through the map, and we're going to use Y to go through the screen. Okay, and we're going to create a loop. So after we do the loop, the first thing we're going to need to do is we're going to need to load the map location into the accumulator. So I'm going to go ahead and use :map, and then we're going to use (x). So what this is wherever the map location is, that's what this colon means, is actually kind of, it's going to take wherever it sees the word map, and wherever we pass it, it's going to replace that with whatever this is. So we're going to say the map location, and with an X offset, we're going to load that into the accumulator. And we're going to need to do multiplication on that. As we said, we're going to multiply it by 2. And there's an easy way to do that with assembly. And we're going to use the ASL operator, which says our arithmetic shift left, which what that's going to do, if you look at the bits, it's going to shift all those bits to the left one space, which actually does a multiplication by 2, because as we know, bits are powers of 2. So it's a really fast and efficient way to be able to multiply by 2. So now we're going to say we're going to send that to the screen. So we're going to say screen, comma, Y. Okay. And so that's going to, wherever our screen location is, it's going to use the, and do an offset of Y. Now, keep in mind, this map and screen have nothing to do with our other variables that we've set up. These are actually kind of, consider them to be local in a way, in that this colon map has nothing to do with map. This colon screen has nothing to do with screen. I'm just using that to kind of, understand what we're trying to be doing there. So we're going to be storing the left character at wherever screen is with an offset of Y. And now we're going to need to increase Y. So increment Y, because we want to move over one character. And we're also going to want to add 1 to our accumulator to do the right-hand side. If you remember, what we were saying is 1 is going to equal 2 for the left, and then 3 for the right. So all we need to do is do a ADC of 1. Now, ADC is add with carry. And since we don't care about the carry flag, which is the thing basically to make it so when it overflows, it actually uses the carry flag, we don't want that to come into play. So what we're going to use is we're going to create, it's a very good practice here to clear the carry flag, which is the CLC operator. So we're not going to be using the carry flag at all, but we just don't want it to ever take effect. Okay, so we've increased Y, we've incremented Y, we've added 1 to our accumulator. Now we need to store that into screen, y. We've incremented y, so we're 1 character over. So this will do the right-hand character. We're also going to need to increment y again, because now we're going to be going to the next character for the next value in the loop. And we're also going to need to increment x. So this is going to go to our next map value, okay? The next thing we're going to want to do here is we're going to want to do this 20 times across to go 1 row. If we look at here, we've got 20 characters across, or 20 tiles across, I should say. So what we're going to do here is we're just going to do a CPX 20. And that's going to say we're going to be comparing it with 20 every time. So basically, we've been doing this before. It's basically a for loop. And so we're going to be going to 0 to 20. And then what we're going to do is we're going to say B&E loop. So if it doesn't equal, branch not equal 20, then it's going to keep going through the loop. And in order to end the macro, we do end m, or .end m. So this is our new macro called blit row. There's a lot more stuff in here that we have to do in order to do this. That's why, doing this way over here, we're able to do it in 1 instruction, but there's a lot more going on when we're dealing with the tile-based stuff. So now we can update our display map function to use this macro. So we're going to use blit row, and the first one we're going to be doing is just going to be the map, and it's going to be then screen, okay? So we're going to be passing in the value of map here. So this is, the first value is going to be a 1, okay? And then we're going to be passing in screen, which is going to be what we have set it to at the beginning, the screen at 4000 hex. And that's the equivalent of doing what we did before here with the MVA map, y and screen, y when it's at 0. Now to do the next row, what we're going to do is we're going to do blit row map. Now we're going to do plus 20. So that means we're going to go 1 more line down. So this is, 20 characters across. So we're going to go to plus 20, plus 40, plus 60, etc. So we're going to do plus 20, and our screen is still 40 characters wide. So we're going to still be using screen plus 40. Okay. And so we're going to go ahead and copy and paste this. And we're going to have to modify them each time here, but that's okay. So we got up by 20 on the map, and then up by 80 on the screen, which is the similar thing that we're doing right here. The difference is we're not doing this with a loop. We're actually just calling the blit row macro that many times. And so let's do this. Now, the thing is about a macro that you need to understand is that it is saving programmer time, basically by doing this. What this will do is it will, when the assembler assembles this, it's going to take this blit row and it's going to paste it into this code right here. So it's going to make our code quite large, but we don't have to deal with it. The assembled code is going to be much larger, and that's okay. It's not a function. It's not something that's going to be called. It's just going to, the macro is just going to basically look at it as being a copy and paste. And that's okay. We only have to do this 12 times. It's not that big a deal. So we're going to go through here, 120, 140, 160, 180, and we're going to be going through here at 160, 200, 240, 280, 320, 360. Now this should be the same exact amount of lines that we had before, so we need a couple more to get to 440 here. So that's fine. 320, so we're going to go to 400 and 440. Keep typing that. Okay, so 180, 200, 220. So this, to get a kind of a checkpoint here, this should be half of whatever this is, because we're dealing with the tile base being, half as many as the characters. So this is looking pretty good. We got 40, 20, 80, all these different ones. So this looks good to me. We don't need any of this code because we're not doing this loop at all anymore. We are just doing this macro code. Okay. So we're going to be calling blit row 12 times. Where it's going to be calling the map each time, and it's just going to be the first time it's going to be sending it. It's going to be sending basically this address here, and then the next time it'll send this address, the next time this address, etc. So it's going to do an entire row. And at the screen, it's going to be doing the first line, second line, third line, things like that. It's going to be doing at the start of each of those. So let's try this out, see if it works. Okay, yay. So it looks like identical to the way it did before. And that's what we expected. So let's look at, let's see, first of all, let's remove this stuff. Let's clean this up a little bit. Let me also add a comment here for the macro, and just so we have similar style here. So we're going to say blit row, and we're going to say blitz. I want to say copies map to screen line by line. We're actually copies one line of map to screen. That's probably good. Okay. And now what we can do is we can have some fun with our map. No, you know, since we're in tile based now, it's a lot easier to kind of work on this. So we could actually just change this all to walls if we wanted to. We could put, like, say, let's put a doorway here, and let's maybe put, and we can do something like, let's put a bunch of walls right here, and maybe some right here, and we can put doors in between, or we can put hallways, or we can do whatever the heck we want here. It really doesn't matter. Let's put some walls, or let's put some doors here just so we can get from one area to another. Let's take a look. There we go. We got a bunch of doors there. It really doesn't matter. We're just trying to, you know, make sure that it works. But that looks pretty good to me. So yeah, so now we have a new display map function that utilizes the blit row macro. And it's about the same amount of code. There's a little bit extra here, but you know, it's not too bad. But it's going to be much easier when we're dealing with the map generation stuff. So there you go. So thanks for joining me today. I hope you liked the video. If you did, be sure to hit the like button. And if you'd like to see more of this content, be sure to hit the subscribe button and ring the bell. If you see anything that needs to be called out, I definitely appreciate it. It's great when you have people that are always looking at my code. It's great to have people comment and tell me what you thought. If you have a better way of doing some of this stuff, I'm glad to hear it. In any case, I will see you in the next adventure. Take care.